Hello, folks. This is Dr. Chris Mullins coming at you from the chemistry labs at Campbellsville University. Coming up October 18th through 24th, right around the corner, we have National Chemistry Week 2015. And the theme this year is Chemistry Colors Our World. That week, obviously the end of that week is October 23rd. And if y'all remember what a mole is in chemistry, those of you fine chemistry students, remember that a mole has Avogadro's number, or 6.022 times 10 to the 23 molecules, atoms, or particles, ions, whatever, per mole in it. So, Mole Day will be from 6:02 a.m. to 6:02 p.m. on October 23rd with National Chemistry Week. And you'll see that 6:02 a.m. is going to be a very important time period for my organic chemistry students this year. Alright, chemistry colors our world. We might remember, I don't have the eye here, Roy G. Biv, our color spectrum, right, represented here in the chalk colors. Right, so remember those fine colors in the color spectrum this year. I want to turn your attention back here for a moment. I've got a little bit of a demonstration, if you will. So, organic compounds that are colored, there are many. There are many organic compounds that are not colored. But here I've got an example that some of my students may have seen previously in general chemistry. On the left here, I've got this nice purple solution. It's really quite dilute. There's not a whole lot of molecules in the solution, a lot of water. This is crystal violet, an acid solution, and it's quite purple. And as soon as you react it with a base, like sodium or potassium hydroxide, once that pH gets high enough, it turns colorless. Right? I'm going to show you another example. A compound here known as alizarin. Right? Its chemical structure shown here. My organic chemistry students should, and those who have had it, should be able to recognize a lot of functional groups here in this molecule known as alizarin. And in water, it's not too terribly soluble. I took just a little bit of it and put it into about 200 mLs of water, about 1/5 of a liter. And you can see there's a lot of it that's not real soluble. And our pH, if we tested our pH, it's probably somewhat acidic. I haven't checked pH yet, but I will in a moment, of that solution. And, alizarin should be a pale yellow color below a pH of about 5.5. So I'm going to make the guess that where pH is somewhere in that range, and I'll check on it and I'll get back with you in just a moment. Okay, folks, so I just wanted to inform those of you that may not be aware that acids and bases in chemistry, remember acids are things that have high concentrations of H plus ion or H3O plus ion in water, and usually in water, well, not always. And then a pH is the negative log base 10 of that hydrogen ion concentration. So things that are acidic have pHs below 7 at 25 degrees C, and things that are basic are above 7, and things that are at a pH of equal to 7 we call neutral. So water that's neutral is pH 7. Okay, so coming back here, I've got a couple pieces of this hydron paper, and we're going to test the pH of our solution. And I will tell you to confirm what it is, and then we'll go on from there. And it looks like we can see here that pH is probably in the neighborhood of about 5, because as we compare it to the hydron paper, 5 or 6, not really any big color change there compared to that. So now I'm going to add some aqueous potassium hydroxide solution, aqueous solution that is colorless, and it's going to shift our pH higher, and we should expect our alizarin then to change colors, we'll see. So alizarin is a molecule that could serve as a pH indicator as an organic dye, and we'll look at this in a moment. Okay, so now I have 40 mLs of this 1.5 molar or 1.5 moles per liter of potassium hydroxide, pretty relatively strong base. We're going to add to our alizarin. We're going to add it just a little bit at a time and watch the color change, a little bit of shaking, and see what happens here. So I'm going to start by adding just a few drops of it. Let me see if I can get my device. Ooh, look at that. We'll shake a little bit, swirl it up. We really did not need to add much, and we went to a very deep purple pretty quickly, right? So we added less than about 5 milliliters, right, of solution there to that. And we see a dramatic color change, and so the pH is somewhere quite a bit higher pretty quickly as our little bit of acid in our water got converted to a basic solution, and that molecule now structure changed a little bit in the presence of base. Okay, so to wrap things up, we see that organic compounds can absorb light and give us many different colors, and my organic chemistry students will again be learning here shortly about an assignment where they're going to need to communicate their knowledge of organic chemistry and relate it to the chemistry of color in the world around us. Thank you very much for your time and attention, and have a very colorful fall weekend.